Today's video, I will be talking about the true nature of light. I've just realized I've made a lot of videos on optics, yet I feel like I haven't covered the most basic, and that is what is light. Now, let's recall. To my spectrum of light video, we talked about light being electromagnetic radiation, and we just touched on it briefly and said that different wavelengths equal different amounts of energy. But what does this actually mean? I mean, in the photo, we see it looks like a wave. Does that mean it is a wave? Well, in the very beginning, Isaac Newton had a leading theory that it was like a particle, kind of like bullets, and they were called corpuscles. But Christian Huygens thought light was ripples through space, which is more like a wave than a particle. At the time, Newton's theory was the most popular because he was just more well known than Huygens. It wasn't until Thomas Young's double slit experiment many years later that they definitively proved one of the two. And this is basically his double slit experiment where light was passed through two tiny holes through a metal sheet that were comparable to the wavelength of light. So you can imagine tiny nanometers in thickness. And on the resulting screen that you see was this kind of pattern of light and dark, like strips almost. And this is actually called an interference pattern. And so why did this happen? I mean, you'd expect if it was a particle, it would create two strips, right? One for each hole. Well, actually, what happens with waves is that when two similar waves pass through each other, when the crests align, they combine to form a wave that is double the size and amplitude. And when a crest and the tiny dip in the wave meets, they cancel out. And so this results in, here's a visual, some parts will construct to build larger waves and some places will cancel out. So going back to our double slit experiment, you can see that in the black parts, it's where destructive interference takes over and it cancels out the waves, and the light stripped parts are constructive interference. And so this kind of proved that light was definitely a wave. And even later, like James Clerk Maxwell, a prominent physicist, came up with the electromagnetic radiation part of light, which said that it was actually two perpendicular waves, the electric wave and magnetic field, that would combine to make light. And so this was a leading theory until Einstein came along. And in Einstein's photoelectric effect, he found that when you shoot light at a sheet of metal, you actually release electrons, and these were captured with the sensors they had at the time. And they found that the intensity of light, meaning how bright or how much light is shown at the metal, does not affect this effect of the electrons being shot out of the metal. And they found that the only thing that mattered was the frequency. And so what they discovered was that these electrons required a certain amount of energy to fire out of the metal that was determined by the wavelength of light, or the frequency. And so the intensity didn't matter. And this wouldn't make sense if it was a wave. This would only make sense if it was a particle, because think of it as if you shoot one photon at it versus you shoot a million photons at it. Well, it actually doesn't matter, because as long as a photon with the correct amount of energy or the correct wavelength was shot at it, it would release these electrons. And so this proved that light can also act like a particle, and Einstein actually won the Nobel Prize for finding this out. And so I hope after this video you can answer the questions I have on screen. As always, thanks for watching, and I'll see you in the next video.